I am Seyed Jafari. I'm a senior software engineer at Auto1, and you can find me on pretty much every social network out there using this handle. So to date, I'm going to talk about what is flow. Flow, by the definition of the docs, is a asynchronous data stream that sequentially emits values and completes normally or with an exception. To me, that's a little bit of mouthful, but what I digested, the way that I digested myself is that it's basically a pipe that events can be flown through it. So as a normal, like a water pipe, but there is like a small, at some point in time, there is a little event at this point, and then the next one, and then the next one, until actually the event goes from one side to the other side. So that's how I imagine flow or other reactive streams. So the very basic and most important rule about flow is that we have to remember that everything is a stream. So this is mostly this picture and this idea is mostly to applied to the reactor streams, but flow is almost the same. So we can actually say pretty much the same thing to the flow as well. Uh, this sentence has a side effect of that there is no specific event in the flow. So you cannot just pick a very specific event from the flow. Of course, you can do operations, but you cannot expect, okay, I want this at this particular time. So everything again is in the single shaded pipe that we cannot see inside, and the events just go from one and to the very other. And in the middle of this pipeline, uh, although we cannot access the events, we can do operations on the events. And that's what we're going to talk about today. So, but first, let's see what a very simple flow looks like when you're creating one. So here I'm creating a very basic flow of events of strings. So basically, I'm creating a pipe that just emits or that will flow strings values, and then I can listen to it. I can actually receive the events from the other side of the pipe using the collect function, and in this case, I'm just printing it. So just with the basic stuff, nothing very crazy. It's just the small value that we pass from one end, and we can receive it or collect it from the other end. Before we go any further, flows are built on top of Kotlin coroutines, which is one of the most powerful features of Kotlin language. And I think everyone that writes Kotlin will definitely fall in love with the Kotlin coroutines. So, and flows are no exception. And flows are built on top of coroutines. For this talk, I'm going to assume that most of us are familiar with what coroutines are. But just for the sake of like being on the same page, I should just mention that uh, a suspend function is a special kind of function in Kotlin that can only be run inside a coroutine scope. And coroutine scope is what manages coroutines, and the coroutines are the things that we can run are suspended functions. And in a simple word, coroutine is a lightweight thread that can be launched from a scope. I said launch because there is a function extension function on a scope that called launch that you can call, and it will build a coroutine on that scope, which we can call our suspended function in. So that is like the most compressed form of presenting coroutines. But again, we're not going to talk about coroutines today much. It's more about flows. All right, so back to the flows. Flows are built with functions. So functions are first-class citizen in flows, and there are three types of flows in I'm sorry, three types of operators or functions in flows. The first one is builders and creators. Like the one that we just saw, with these ones, we can create a flow. There are different types, there are different ways, and there are different ones. We will go through them in a bit. But the next type of the operators, which we will focus the most in this talk, is that intermediate operators. These are the ones that we put in the middle of our pipe in order to modify the events as they go through this pipe. As I said, we cannot just pick any event and then modify it and put it back there. So we need some way that some sort of operator that will modify the event as the time goes by. So that they're called intermediate. And the last but not least is the terminal operators. These are the ones that we can actually use on the other side of the pipe to listen to the events or receive the events that are flowing through this pipe. All right, perfect. So now to start by checking and seeing what are the builders and creator operators. The first one, we just saw it. It's a flow of. It is the very basic one. So basically, you just pass variables to this vararg argument function, and then this function will create a flow for you and will emit every item that you have passed to the as a parameter. Very basic and very simple, and it's very handy. So if you are familiar with KotLand language and you're using list of, this is basically the same thing. The next one is an empty flow. If you want to just create a flow without emitting anything, this is very useful, and it's just a handy tool that is out there. Flow, if you check it closely, you can see that the first letter is actually lowercase. So you can see with this function, it's not a class that you're creating. It's a function that you're using to create a flow. This is the very low level construct to the way we can create a flow. We pass a lambda to this function that we can get the control over how flow emits the events that we like to. The next one is callback flow, similar to the previous one, the flow function. It also needs a lambda, but the difference is that we can, in this lambda, we can actually create listeners that run on a different context or different threads and emit events from a different thread into this flow. So it's a very nice tool that allows us to bridge between the flow world to the normal listener or callback world. And the last one is the channel flow. This is the underlying implementation detail for the callback flow with a small subtle difference, which we will talk about in just a sec. And then there are also extension builders and creators that allow us to convert other types to the flow. So one of them that I found useful from time to time is the as flow on the list type. This is basically the same thing as the first creator flow of, but it will take every element in the list and it will put it through our pipeline. So this is just a handy extension function thanks to the KotLand language. Next one, this is a little bit different because this extension function works on a list of flows, and we will talk about merge and how it will work, but since it's a builder or creator of function, I have to mention it here that it will basically get a lot of flows and it will combine all of them or merge them in a better word, and will event all of the pipes into a single one. So at the end, we will need only one receiver or listener to receive all of the events from different branches. So as I said, callback and channel flows are very handy, but I need to let's see how they work, and I need to show the different a small difference that they carry with each other. So here I'm creating a callback flow, and as you can see, I'm creating my listener. In this case, I'm creating a listener for a location manager that I have in my application. It can be any application. And in the on success, which is like a callback from this listener gives us updates on the user's location. And in on success function, I call send blocking. This is an extension function on the callback flow. And since I just want a single event to be put through in this pipe, I will close this flow immediately after I receive it. So right after the send blocking, you can see that I'm calling channel.close. But where does this channel come from? As I said, callback flow is basically a sugar or a helper function on top of channel flow. So this channel flow creates a channel and pass it to us in this lambda that allows to emit events to the channel, and channel is translated to the flow for us. So that's why the returning type of the callback flow is a flow, not a channel. Down there, we're registering the listener to the location manager, like that is the API that needs to work. But here comes the interesting part. So await close is a suspend block, and it will suspend this outer block, the callback flow block, until we call close on the inner channel, or someone will stop. The listener will stop listening, or the scope is closed, as I showed earlier. So in either of these cases, this await close will get called, and then it will finish the suspension. Here is the most important difference between channel flow and a callback flow. If you're creating a channel flow, you don't need this await close. It's optional. You can have it or you cannot. You can omit it. But if you're creating a callback flow to help you stay on the safe side, if this await close is necessary and need to be called before the function ends. The reason for that is because if you don't call this await close immediately after the registering of listening, the flow will close, and you cannot actually send any through this pipe. So to avoid closing this pipe until we are actually done processing, then we call await close. I hope that it actually makes a bit of sense. I should actually mention here that this flow is a cold flow, but don't worry about coldness or hotness. We will talk about them later. All right, so that pretty much concludes the most important builder or creator functions for the flow. Is the intermediate flows, as I showed, and there are quite a lot of them on the flow. Here is just a quick glance. We will go through. I think, we will go through all of them, and I think this is the most important part about flows that we need to understand in order to utilize the flows the best way possible. One thing to note here is that this partitioning that you see between the operator is totally mine, and it's not in particular order. All right, so the first part. As you can see, I'm just keeping it simple. I'm creating a flow using a flow off creator function, and I'm just passing a couple of parameters as an argument to this function. So as I've explained, this flow off will create a flow for me and return it. But on this flow off, I'm calling filter, exactly like how filter works on the collections framework on KotLand. This works the same. So I'm filtering events that are empty of empty string. So I don't want empty string. It doesn't make any sense for me. So I'll filter it. So the downstream, anyone listening from this moment on, they will not see any empty string events. And the next one is, again, super simple. We are converting from integer to string. My pipeline starts from emitting events on an integer type, but on the other side, I want a string. That's how I can actually map it to. The next one is with index. This is just a helper function that allows like counting the events that are going through the pipeline. But just be careful if it overflows than an integer, then you will have an exception and will close the flow. So with index, we'll actually return object that holds the index and the value of the event itself. The next one is drop. So this is one of the handy operators that I usually use it. If the flow is emitting too much at the beginning and I don't need all those emissions from my purpose, maybe someone else is needing them, but I don't need the first one or first two, then I drop them. So let's say that in this case, the flow emits 3 events. Sorry, my camera, I think, stopped working. Let's hope. Okay, I'm back. Sorry about that. The flow emits like 3 events, and then I'm just interested in the last two. So I drop the first one, and then I go listen to the last two and three. All right. The next one is the opposite. It's take. So again, there are like a lot of events going through this pipe, but I'm interested only in the last. Sorry, in the first or the first number of events. In this case, only the first event. So you can take the 1 and 2 and ignore the rest of the events, in this case 3, and stop the flow from flowing. The next one, this is very, very useful. So if you have duplicate events, or if you think that the flow or the pipe is crowded with all the duplicate events and you're not interested in them, you don't need them, you want to make sure every event you receive is unique, then this is the easiest way to do it. So you call this thing until changed, and it will immediately stop publishing new events that are identical to the previous one. Uh, but it only checks the last event. So in this case, we're emitting 3, 1, and we will receive only 1 because they're identical to the previous one. And then we will emit 2 different. Okay, so we receive it. And then the 1, the previous one was 2, so we will receive a 1 again, and then the 3, which is completely different. So that's something to keep in mind. There's also another variant called distinct, which will check the entire like the events, but usually this is more useful. All right, the next one is buffer. Okay, so buffer, what does buffer do is that splits our pipe, or from now on, I'm going to change the pipe to stream to make more sense. Splits our pipe or stream into 2 sections, upstream and a downstream. Whatever is on the top of the buffer will function as normally, but whatever is on the bottom side of the buffer will function in a buffered fashion. But what does it do is that uh, if uh, if the collection is if the collection is very slow, let's say we are writing if we are writing to the database and the database is very slow, then the buffer comes in handy because it allows us to the upstream flow can function at the same speed. It doesn't block the upstream flow or suspend the upstream flow, and keep let's say a cache that will emit with the speed that the collection can handle. So in this case, you can see that the delay is we have a delay of 1,000 for each event we receive in the collect. And we will talk about collect later, but just for the sake of example. So it takes 1 second to process every event that is going through this stream. But the stream is emitting events as soon as possible. It goes super fast. And If you check down at the comments, you can see that on each is getting called like with, but since we have a delay, buffer will buffer or will cache all the three events for us and gives them to the collect in the correct order, but with a delay. If the buffer gets full, then this buffer overflow will actually come in handy. If the buffer is full, then I'm just asking the upstream to suspend. This is when the upstream will get suspended. So until you don't have a full buffer, then the upstream will continue going normally. All right. So the debounce is actually next one, and it is another very handy tool that can help us use the flows efficiently. So the way that debounce work is that you pass a time, in this case 100 milliseconds, and as long as the time window is not finished, it will ignore the last event. So let's go through it together. We are emitting one, event of one, and then we are delaying for 50 milliseconds, and then we are emitting the second event, which is two. But since we're using the bounce with 100 millisecond delay, and the one and two come very close in a matter of time together, so it has to drop the first one, which is one, and then continue just with the last one that exists in the cache, which is two. And then it goes on with it continues. So we are emitting two. The window is finished. The 100 millisecond window is finished. We receive the two, and then there is another delay on delay of 150 milliseconds, and there is a three. Since 150 milliseconds is enough for our debounce to finish the job, then we will have the two and the three together receiving. All right, so now moving on to the second part of the intermediate operators, and I'm gonna start with on start. So on start is super handy. If you have a very long chain of operators on your flow, but at the very end you decide, all right, I just want something from my flow to be on the first event. I want to receive this event as the first element. But how do I do that? This is where the on start comes in. So you can place the on start in anywhere in your chain, but just remember the one that is on the bottom will emit the first. So the bottom one is bottom first, top last, something like that. um, the um, Okay, so in here, in this case, we have a flow of 1, 2, 3, and then another and on a start, which will take precedence over the original flow, and then another on the start which will take precedence on the previous upstream. So if you can see, the output is starting from 5 and then 4 and then 1, 2, 3. One of the cases that is actually super useful is that when you want to just emit a loading, or you want to emit something that indicate, okay, I'm doing something in my processing, just wait for me, and then when it finishes, I'll give it to you. So loading in a terms of reactive world is very useful, is a good example of emitting on a start. The next one is on each. This is very simple, yet very powerful, because it sits on the flow, not something outside. It is a side effect. And if you're coming from a RX Java or RX Land, this is exactly almost the same as do on next. And the difference is that if you suspend the on each, in this case, I'm delaying for a second, as opposite of the do on next from the RX Java land, this will suspend the entire upstream. So as I said, this is sitting on the flow, not as a somewhere outside. So anything you do, like a time consuming, this will stop or put the pressure on the entire stream. But the use cases for on each is that You can log, you can do the side effects of the events. So let's say there are lots of events going on. You just want to see what events on each point of time has been emitted. You can just bang on each and your operators and just log them to your database or file or wherever you see it fit. Cool. The next one. All right. So we have shown that we have the next one, sorry. The next one is on empty. We are creating a flow of 1, 2, and then we are filtering any event that has an integer of less than 5 or 5 and less than 5. So basically, if you're just checking it, this means that there will be no event flowing through this flow. So what happens is that our flow will finish and says signals that, hey, I didn't have any flow. And that's where this onEmpty will come in handy, because then we can actually, it's like a check. So if my flow was empty, then do this. And in this case, I'm actually emitting another flow into this, into the downstream. So the example here is that, okay, I'm gonna fire a request to another server, and this server doesn't return me anything. But in that case, if the stream is empty, I want to emit something from myself. Okay, I have this from the cache or from database or from another server. Then if my original server failed, or if it's not failed but empty, then I'm gonna use my own stream. All right. Just keep in mind that that for this operator to work, it needs to emit the flow needs to emit the emptiness, which will come in very important later down the talk. All right. The next one is on completion. So similar to, oh my God, this is not what it should be. Okay. So similar to, sorry for the camera interruptions. I don't know what is going on. Similar to the on empty, if the flow finishes, then we get a call. We can get a callback as well. So on completion is a good operator that will indicate that, hey, your flow finished. There is a subtle difference, is that this is not working on the upstream. The uncompletion will work actually on the downstream as well. So if the exception happens on upstream or a downstream, so let's say your collection, on the collection point, you throw an exception. Usually we cannot catch that, but in this case we can. If you call on completion, the moment that the flow is being canceled via an exception, your this block will get called, and you can do whatever you think see fit. Mm, and the parameter is a throwable. You can check if the throwable is null or it's actually exists. This way you can make sure that the flow finished or completed safely, or something went wrong. If it was say if it completed normally, then you can actually emit more events. It's like doing the final thing. All right, I did everything here, but I need this this last event to be flown as well. Sorry. All right. So, and also if you have an exception, since it covers both upstream and the downstream, I think this is the only operator that will actually cover the downstream. You can actually log it, or maybe do whatever you want with that throwable. Cool. The next one is I'm actually presenting two of them together. It's retry when and catch. But let's start with the retry when. So what it does is that retry has a couple of variants. One of them is when. The other one is just retry, empty retry. And what it does is that it reconnects the pipe or the streams to the publisher. In this case, I'm creating a flow, normal flow, and I'm just immediately throwing in an illegal state exception. All right. So by putting a retry event right after my flow creation, it will actually try to rerun the flow block, the flow creation block, again and again for 3 times. This operator is very powerful because it gives you the exception as well as the number of times that the retry operator actually retried the original flow. So let's go with an example. If you have a network that is not stable, using retry when allows you to check the cause. Okay, I got an IO exception. There was an exception going on when I was actually transmitting the data. This allows the flow, and my flow was canceled. You say this, if this is the exception, it happens, then retry the connection or the emission to the backend for 3 times for me. And that's a good combination. And if no exception happens, happy ending. Your flow just keeps emitting flows. Oh, sorry, events. But let's say in this case, my flow, of course, will never succeed and it will always fail, even after 3 times, because I'm just throwing exceptions. So what happens is that then, depending on what we have next, we can actually catch the exception and decide what we want to do with my flow. All right, in this case, I'm just emitting. I'm just checking. I'm not done. I'm not. Sorry. I'm not doing anything crazy with the throwable. I'm just emitting a new event. So the downstream, anyone from catch to the bottom will not know that an exception happened upstream. They will never know. So let's say again, your database failed. It gives you an exception while trying to query the database, but you still need uh, some events to be published to the downstream flow. What you can do is you can just use your memory cache, and if there's an exception in your database, you can just emit your memory cache to the downstream. So that's super handy. One thing to note, as I said, incomplete is the only operator that gives you the exceptions for the downstream. Catch will not do that. So if anything happens below catch, you cannot get it, and it will be and it will cause the flow to close. Just be careful with that, even if it's in the collection point. All right. Uh, the next one, actually, the next part. In here, I'm going to talk about flow on. This is the only operator that allows to switching context on the flow. And it works from bottom to the top. So if you're applying flow on, in this case, I'm creating the flow. Immediately, I'm applying flow on. This flow on will change the context for the top side. Um, and So the default dispatcher will get applied to the creator function. I have another flow on. This will work on each only because it will reach. Okay, let's say it wraps the on each, and then it checks what's on top of the on each. It says, oh, okay, there is a flow on. I don't need to worry about that, and it will quit. Okay, so the way it works is that my flow starts from the default dispatcher, will emit the on each on the IO dispatcher, and will emit to the collection point depending on the dispatcher of the collector. So keep that in mind. One more very important note to keep in mind in the context switching, that is very expensive. So switching threads or contexts are very expensive. So make sure that you are changing context whenever you actually need it. One of the good use cases is that, again, on a database or a server call, you might want to use an IO dispatcher or flow on IO to help with threading and suspension. Cool. That one was a quick part. Now let's go to the next one. So this one, I'm gonna talk about transform. So transform, I think it's one of the, again, one of the low level operators. This, and it is very powerful because lots of other operators are actually built on top of this transform. And if you check out, I highly suggest to go and check out the implementation for the transform, because under the hood, it's actually not that big of a deal. It's creating a new flow, and it will call the lambda in the collection point of the original flow. So nothing really crazy, but it provides such a like powerful lambda or construct to your flow chain. And in here, okay, let's see what we can actually do with this transform. I'm doing two things, or actually three. First, I'm filtering. So I'm checking if the event that is coming to me is empty, then I don't need to do anything. I just return. The next time is that if it's not is not empty, the event is not empty, then I want to fire a backend request. I want to call some APIs, do a search, and return the item. Since all of the operators in on the flow is gives you a suspend block, you can actually call another suspend function in your transform block. In this case, I'm calling an API request. So it returns an API request. Great, I have my response, I have my search response, and now I want to emit it. You can do that with the transform. You can just call emit like the way you do on your flow creation, and just emit your events. As you can see that I'm not emitting the same number of events that I'm receiving. I'm emitting the number of events that I like to emit. I can just stop emitting completely. All right. One of the cool things about transform is that it kind of translates from the imperative world to the functional world. So, so you can actually come as exactly what I'm doing here is that I'm converting a normal function call to a flow functional pipeline. All right, I need to be a little bit quicker because there are lots of slides going on. Hopefully I can finish. And here I'm using the transform, and here is the body that I talked to you about. So it's a normal flow. All right, so the next one is zip. It is actually intermediate. So it zips two flows together, and each events from one to other one will be zipped together. It's very important to know that the events has to the number of events has to match. So if the first one emits two events and the second one is only one, you will at the bottom you will only receive one event because the second one didn't emit anything. The next one, sorry, I'm going a little bit fast. I need to get to the more important part as well. So the next one is combine. This is my favorite. So if you have a flow, but you want to combine it or mix it with another flow, combine is a very powerful and a friendly operator. So you can just pass your another flow to this combine operator, and it will give you the events for the both flows. The difference between combine and a zip is that the number of events don't need to match. So so here I can just the first one will just receive a list of books, and then I'm just another flow for me is getting some queries for the name of the books, and the queries are keep coming to me, but the book list is only a single event. So I get the book list every time, the same book list every time the query changes. That's how powerful it is. So you can observe your database, but if there is a new query, you can just perform it on the event. All right, now there is a set of operator called flat map, and I'm just going to go through them quickly. Flat map merge, flat map contact, and concat, sorry, and flat map latest. So flat map merge is that it will merge the events that are emitted by the inner flow or inner stream to the outer stream. So the flow in here, the main difference between flap maps and the normal map is that for the normal map, you have to map or convert your event to another event. But here we are converting an event to another entire new stream. So I'm returning a stream for every event that I'm receiving from the original flow. This is interviewers usually love the difference between map and flat map. So memorize that if you have an interview coming up. So here you can quickly see that I'm creating two values. Sorry, I'm creating a stream for each value, but since I'm using flatmap merge, the order is not guaranteed. So I can receive A1, A2, and A3, and then I'll start receiving maybe B1, I guess, and then B2. It's not guaranteed. So you can see that it's coming, but the order is not guaranteed. If you need the order to be in the same that you're emitting from the original flow, then flatmap concat comes in very handy. So with flatmap concat, you can actually keep the order preserved, and but just be careful because you cannot use as much concurrency as the flatmap merge because the order has to be in the same. And the last, but again, one of my favorite ones is the flat map latest. It's actually one of the most useful operators in the world of reactive because for every event coming from the original one, it will create a flow. But for the second one and upward, will cancel the previous flow that you return in a favor of the next one. So here, I'm getting a delay. So I get a 1, 2, 3 goes. But since I have a delay of 50 milliseconds, it will skip the previous internal flows that it created in favor of the last one. All right. And one of the use cases is that you can have a query on your database and observe your database. So if the query changes, you don't need the previous observing of the database. You can just skip that and start observing for the new query. So that's how useful it is. Part 5, this is reduces. If you're coming from the Redux or I think React Redux background, you're pretty much familiar with this concept. There are running reduce scan operators. So running reduce will give you accumulator, which will actually the event that you publish will be cached and will be given to you upon the receiving an upstream events. So here I get 1 and it will cache it for me. And then for the second event, which is 2, it will give me 1 and 2 together. And in this case, I'm just multiply them together. So the next event will be 2. And the last one is 3. So the 2 is from the previous one, 3 is from the new one. I'll multiply them together and I get 6. Scan is like the brother of running reduce, but then you get the initial event to be passed from the outside. This is again very useful, which you can use from if you want to pass if you want to inject something into your pipeline. Scan is very useful. All right, terminals. I think I'm close. Terminals, there are again a number of
Said,
terminal
no
operators.
rush. I think we have like 5 minutes, no problems.
Okay, that's great news. Thank you so much. I can slow down a little bit. Okay, so for the terminals, I again split them to sections. So collectors, these are the basic ones. You can just call collect on a flow and start collecting. You can call collect index, which will index every event that is coming to you. And then the last one is launch in, which will receive the scope. Just remember that the terminal operators have a very big difference. The terminal operators are suspending functions, so you need to call them with a scope or within a coroutine, as opposed to the other operators, which are just a normal function call on the flow. The launching will just start the flow, and if you don't have anything, we'll just, it's like you're not interested of it in any of the events. You just start doing it for me. The next one is the collection collectors. So you can convert your flow to a list. It's basically the same thing. It will start listening to the flow, and as soon as you it receives the complete signal, the flow says, "Hey, I'm complete." It will create a list and will return it for you. It is very important because you don't always receive the complete signal, and we will talk about it. The set is very similar to list. It will just create a set. So if you have a duplicate, it will just be omitted. The next is first variance. So you can have a single and first. So first is just give me the very first event that comes into this flow, and then I'm done. But the single is like, okay, give me only the single event that is in the flow. So if there is a two events, then it will throw exception. It's useful, but be careful. Reduces, again, we have reduces as an collector terminal operator as well. In this case, reduce, doing the same thing except that the reduce function is suspending function, and at the result is not going to emit any new flows. It will actually give you a single value. In this case, 6 is the last value. And fold, again, it's like scan, but as a terminal one. You get to inject the very first element into the pipeline. All right, so now we talked about flows operators, but we should talk about flows types as well. So we have a cold flow and hot flow. Now we're talking about weather, but I'm not a news speaker. I'm talking about flows. So some people like it cold, some people like it hot. Let's explain the cold flows and the hot flows by an example. So I want you to imagine a rowing bow and a car engine. So a rowing bow it starts moving as soon as the people starts rowing. But the car engine, when you start it, it will just keep running, no matter if you're actually moving the car or not. You're just keeping it idle. The engine is running. So that's the way I like to wrap my hair around like hot and cold. So if the flow stops whenever you stop rowing or you stop listening, then that's a cold flow. If the flow doesn't stop and will continue regardless of you listening or not, that's a hot flow. So I hope I made it easier for you guys, but that's the example that always helps me. And let's look at, so far what we have seen is just a normal cold flow. So if you start listening or start rowing, the flow will start. The moment that you stop rowing, there is no flow, there is no emission, and the flow will cancel completely, as I've shown you in the callback flow. So the cancellation is important over there. The stopping of the rowing is important. But now I'm going to talk about the hot flows or the car engine. So we have a shared flow, which is the basic construct or the low-level construct, and the next is a state flow. So a shared flow can be created two ways: mutable shared flow, or you can actually convert your cold flow. Let's say you have in this case, I have a normal request, but I want to share the events that are coming into this cold flow with a number of listeners. I can use operator share in, which will return actually another flow, which is hot, and share with multiple people or multiple listeners. Just note that for the sharing to work, you need a scope to be passed from outside. And by passing the sharing started eagerly, I start listening immediately after this operator is returned. And the shared flow emitters, you can actually use shared flow.emit, which will emit a new event on the shared flow, or try emit, which is not a suspending function and can be super handy. If you're coming from an RxJavaland, these are very similar to the public subject or subjects. or processors. There's actually called a term processor. State flow is built on top of the shared flow, and they're very similar. But the difference is that state flow has only one cached value and is only one value based. So it's very useful for you when you are publishing your states and you want multiple listeners, or you want listeners after the listeners to be able to listen to you, and it will immediately whenever a listener is subscribed or starts collecting, it will give the listener the last emitted value. So it's very handy in a state-based UI, for example. Last section in my talk, sorry, I'm going over my time, is testing. We cannot leave the talk without testing. So testing of flows is quite easy. You can just call run blocking on your flows, on your test block, and then convert your flow to a list and then assert normally the way you do on the list. But if you have a shared flow, then testing is quite is different, because shared flow cannot be converted, or a hot flow cannot be converted to a list, because there is no completion signal, because it never completes, and you have to be careful with that. There is a library, thanks to Square folks. There's a library called Turbine, which gives you a nice handy extension function. You can call test on your flow, and then it gives you the power, so you can just expect item or cancel and ignore the remaining events and assert based on the items that is passed to you. All right, so there are two open source projects. The first one is Rion, is my own side project. You can check it out. It's built on completely on top of flows. The architecture is completely reactive, and you can see the implementation for pretty much all of the operators as I have shown you here. The next one is Flow Marbles. Flow Marble is a very good demonstration of each operator, and it gives you a quick glance. Okay, if you forget something, it will quickly remind you of what that operator does. And with that, I'm going to say operation successful. Thank you so much for listening, and I'm very sorry that I've gone over my time.